Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 8 from the Smith Organic Chemistry textbook. And this problem asks us to draw a stepwise mechanism for the conversion of acrylonitrile to polyacrylonitrile using butyl lithium as our initiator and carbon dioxide as the electrophile to terminate this chain reaction. We should remember that these anionic polymerizations are going to take place in 3 parts. So there's an initiation step, a propagation step, and a termination step. So I'm going to abbreviate the initiation step with I. So starting with the initiation step, we have our butyl lithium. Oof. Okay, so butyl lithium is going to begin by attacking our first monomer here. So acrylonitrile. Right. Okay, so that's the first step, the initiation step. And as a result of this initiation step, the molecule that we actually end up with will be this. I do apologize. I'm having some lag issues. So I don't know if it's showing up for anyone watching as slowly as it's showing up on my screen, but that's why it's taking me just a little bit to write these. Hopefully that will go away as the problem progresses. Okay, so what we end up with is the butyl group having added to the acrylonitrile. There we go. And we have our lithium cation. Okay, and so we now have an anion, negative charge on that carbon, and as I said, the lithium cation. And so we've made our activated species here, our initiated species. So that's the entire initiation step. So next, we're going to have our propagation step. So we'll call that P. And the propagation step is going to consist of this activated species that we made in the initiation step. Okay, so here is our anion. Again, this is an anionic polymerization, so obviously an anion is going to be Jesus. Okay, so sorry. There we go. Right, so obviously this is an anionic polymerization, so an anion is going to be key to that. So our activated species will go ahead and attack another monomer of acrylonitrile. So like this. So the anion attacks there. The electrons of this double bond will shift to that carbon. And what we end up with here is now a dimer. Oh man, not again. I apologize. I'm not certain what's wrong with my tablet here. Um, okay, so there we go. So we've made the dimer here. There is an anion located here now on this carbon. And so essentially the propagation step is going to repeat. So essentially the propagation step is going to repeat over and over again. So I'm just going to write repeat. And each time that it repeats, our polyacrylonitrile chain will grow by one acrylonitrile monomer. And so lastly, we need to end this chain reaction. So that will be the termination step. And the termination step, we were specifically told for this problem to use carbon dioxide as the electrophile with which to terminate this chain reaction. So obviously that's what we'll do. So here is, oops. So here is our polymer chain. Remember that squiggle notation shows that this chain is continuing basically indefinitely in that direction. So we'll just draw two subunits here. So there's a nitrile. There's a second nitrile. And of course, the reactive species here, the place from where the chain is growing, is going to be an anion on that carbon to which the nitrile is attached. And again, we were specifically told for this problem to use carbon dioxide. So here is a molecule of carbon dioxide. Okay, so there's a molecule of carbon dioxide. And so rather than attacking another acrylonitrile monomer, our polymer chain this time attacks this carbon dioxide. And so that's going to look like this. So this carbon is attacked. One of these double bonds will break like that, and the electrons will revert to the oxygen. And so we end up, rather than adding another acrylonitrile unit, we add a carboxylate group. So our product after this termination step is going to look like this. So here's our squiggle again, the notation indicating that this chain extends indefinitely in that direction. So here are the two subunits with which we started this step. So there's one nitrile, two nitriles, And then now, instead of adding another acrylonitrile, we've added a carboxylate group. So C double bond O, single bond O, and a negative charge on that oxygen since it has an extra lone pair. And so that terminates this chain reaction. And so that's the mechanism for this, which is what this problem was asking for. So remember, these anionic polymerizations, you're going to have an initiation, a propagation, and a termination. And in this case, we were given an initiator and a terminating agent to use. Yeah, and so that's the answer.